Ladies and gentlemen, señoras y señores, hello and welcome to this presentation. We feel very honored to be invited to this seminar, and it is a pleasure for us to provide to you our view on global trends in digitalization for legal metrological control. My name is Julian Haller. I'm a scientist engineer metrology at Sartorius Metrology department since 2016, and I will guide you through this presentation. The structure of this presentation will be as follows. I will start with a brief introduction of Sartorius and then proceed to the topic of digitalization legal metrology. There we'll start with a short summary of the status quo, then briefly present some important current projects, and finally show you the future vision of legal metrology control in a digitalized environment. So as mentioned, I would like to start with a brief introduction of Sartorius, who we are and what we are doing. Sartorius was founded in 1870 by Florin Sartorius after he developed a mechanical balance with hitherto unknown precision and accuracy. Since then, Sartorius has introduced several developments and innovations to the weighing sector, being a well-known manufacturer of high-quality weighing instruments since more than 150 years. Weighing technology still is an important part of the company's lab products and services division. A second milestone of the company history happened almost 100 years ago in 1927, when membrane filters were added to the company's portfolio, which was the basis for the development of the Bioprocess Solutions division. Nowadays, Sartorius has more than 60 locations worldwide, with Göttingen in Germany still being the headquarters. The company had 14,000 employees at the end of 2021, and has meanwhile, over the course of 2022, exceeded the number of 16,000 employees. The sales revenue was almost 3.5 billion in 2021, and the company's target is to achieve 5 billion in 2025. Sartorius has strategically focused on the biopharma market several years ago, being based on two main divisions. The Lab Products and Services division provides pharmaceutical companies with several laboratory devices for the development of molecules, cell lines, and processes. And the Bioprocess Solutions division provides them with instruments and parts for the production of biotherapeutic drugs. Although balances, meanwhile, are only one of several instruments of the company's portfolio, and although they are the only type of instruments from the portfolio for which legal metrology regulations apply, Sartorius has always been and still is active in legal metrology topics via participation in several international committees, and Sartorius has always been striving for further development and innovation in this field. The metrology department of Sartorius covers all three classical pillars of metrology: legal metrology, applied metrology, and scientific metrology. In legal metrology, we deal with type approvals worldwide, performing conformity assessment of devices to be brought into the market, so Module D in Europe, UKCA in UK, and VCAP for the US. We run a manufacturer's testing laboratory accepted by the OIML, and in several European countries we run a respective inspection body for verification of weighing instruments in the field. In applied metrology, we run an accredited calibration lab for mass, weighing instruments, and volume. And in scientific metrology, we are active in committee work and with the consultation of customers and colleagues on measurement uncertainties, tolerances, and qualifications. To give you an overview, in the last 3 years since 2020, we have obtained 22 European type examination certificates, including revisions, accordingly also 22 OIML CS certificates, and more than 100 national approvals worldwide for weighing instruments. Now I would like to come to the real topic of this presentation, digitalization and legal metrology. And I would like to start with the status quo. How are things and processes currently handled at Sartorius? In order to get an overview of the status quo of digitalization and legal metrology, let's first have a look at the life cycle of a typical instrument in legal metrology. It all starts with the development phase, where the legal requirements from respective regulations are implemented to the product development team as user requirement specifications. And once developments are finished, they are tested against the respective acceptance criteria. In the approval phase, we will apply for an approval and submit respective documentation. The application and the documentation are then assessed by a respective notified body. Testing of defined measuring instruments will be carried out, and in the end, finally, an approval certificate is issued. In the production phase, we perform zero series testing and a release of the zero series. We test against the requirements. We perform conformity assessment of the new devices, and we periodically perform product audits of all devices series. In the market phase, usually the user of the device has to register at a verification authority. Market surveillance takes place, as well as periodical re-verification inspection. In case of new software versions, there might be an update after having a respective revision of the approval, and it might happen that an instrument has to be repaired in service with a respective re-verification afterwards and an inspection report. Concerning digitalization, let's have a look at the tools and formats Sartorius is using for these steps. So in the development phase, we have the respective requirements and all documentation in a system called Polarion. In the approval phase, we usually submit everything as files, so might be images, Word files, Excel files, PDF files. In the production phase, we of course have tools like SAP for ERP purposes or Tableau for business intelligence purposes to optimize efficiency of the production and to have an overview of the production. In market phase, there might be the possibility to enter information to verification authorities via a respective web interface, or a PDF is sent via email to the verification authorities. It is eye-striking that through all these steps, similar information is needed, transferred, and assessed. For example, the software version, the MPE of the devices, compliance with the respective requirements, dates of conformity assessment, verification, repair, and many others. So the status quo at Sartorius and probably also at other manufacturers is that all information that is necessary through the life cycle of the instrument is available somehow digitally, but it is not fair, which means findable, accessible, interoperable, and reusable. So it will not be easy to find the respective information due to the different formats. The same applies for accessibility. It will not be accessible easily due to the different formats, and also not interoperable and not reusable. The drawbacks or pains of this not fair data is that you have several copy and paste errors, misunderstandings and need for clarifications. Values might be transferred without or with the wrong units, and the same information has to be entered again and again through the life cycle of such an instrument. Let's now have a look at several projects and collaborations that are currently going on concerning the digitalization in legal metrology. The first project I'd like to mention is the development of the so-called digital SchemaX, which is a very promising approach driven by the German National Metrology Institute, PTB. You might be familiar already with the approach for harmonized machine-readable schema for digital calibration certificates, the DCC. And the idea of the digital SchemaX is to expand this approach to other certificates and protocols in metrology by defining similar schemata. The approach of particular interest for this presentation is the DCOCM, the Digital Certificate of Conformity Metrology, which would allow for a harmonized machine-readable representation of the approval certificate and the included information. So as you see here schematically on the left side, you would have the machine readable information in a respective XML file, which with the aid of a XSLT file can then also be represented in a nice human readable format. But the important part is that you have all information that would be covered by a respective approval certificate in a machine readable format according to this digital SchemaX approach. The next project I'd like to mention is the revision of OIML R76, which is of course driven by OIML. This is not a digitalization project per se, but clear separation of single requirements from explanations, notes, examples is an indispensable prerequisite for machine-readable requirements, so-called smart legislation. Let me demonstrate that on that example of this paragraph here from the current OIML R76. If you take a close look at this paragraph, you will notice that it actually contains 3 requirements. The first one is that an instrument may be fitted with an automatic or a semi-automatic span adjustment device. This could be mathematically and clearly formulated in the following way. An element describing the span adjustment device must be none, XOR automatic, XOR semi-automatic. And the respective documentation could look like this, that the element has the information semi-automatic in this example. Don't worry about the syntax, this is only a schematic example of this presentation. The second requirement is that this device shall be incorporated inside the instrument. And again, you can find a mathematical formulation for that requirement. If the element is automatic or semi-automatic, then realization must be inside. And as you see on the right side for the documentation, you could have the information realization inside in the respective element. Now, it might not be sufficient to only write that it is inside. You might need some evidence for that. So another mathematical requirement could be, if the element is automatic or semi-automatic, then evidence must be existent. And this is again demonstrated on the right side. In this case, the evidence is given in document ABC. You could even imagine that after submitting this documentation to a notified body and after the document ABC has been checked and accepted, the information that it is accepted could also be included in this documentation. The third requirement is external influence upon this device shall be practically impossible after securing. And again, you will find a respective mathematical formulation of this requirement. If the element is automatic or semi-automatic, then, for example, realization must be hardware seal or software protection. In this example, you have realization via hardware seal, and again, the respective evidence is given in document DEF. And you also have a software protection with the evidence being given in document GHI. Now, although this is just a very schematic example of how a smart legislation could look like, you can easily imagine that all of this is only possible after having clearly separated all single requirements from, for example, OIML R76, from respective explanations, notes, examples, and clearly demonstrating and identifying, for example, also if clauses, if something applies only to a particular kind of devices. The third project I'd like to mention is the so-called MetrologyCloud or QI Cloud, which is driven by PTB. The idea is a secure process-related data exchange between the different partners. And actually partners means in this case all stakeholders involved in legal metrology. So the notified body, in this case the PTB, the manufacturer, the user of the instrument, and the market surveillance. And of course, you can imagine that in such a cloud system, several actions would be possible. So for example, all stakeholders can input respective data and set access rights. But you could also imagine that, for example, the manufacturer submits a new software version for the instrument to the cloud. It is checked, assessed, and then released by the notified body, and could then be downloaded, for example, directly by the user. So what you would have actually is, for all stakeholders in this process, an own view with own possibility to give access to their data to the stakeholders that they want to. So for example, for the manufacturer, you would have a dedicated view. For the user of the instrument, you would have a dedicated view. For the market surveillance, and of course also for the notified body. There are, of course, a lot of further projects and collaborations going on concerning the digitalization in legal metrology that I cannot all present in detail, but at least would like to briefly mention. The OIML has recently founded a respective digitalization task group to deal with digitalization topics in OIML purposes. The PTB, together with the German Machinery Association, VDMA, is working on a project called Certificate in One Day, which of course is strongly relying on digitalization. And WELMEC, the European Corporation in Legal Metrology, is currently founding a digitalization group and has a working group 7 software, which is dealing with general software topics, and for example in a subgroup for the recast of the WELMEC Guide 7.2, which contains the requirement to software of measuring instruments in legal metrology, is applying more and more risk assessment approaches for the respective software. And now let's finally come to the vision. How can processes in legal metrology look like in the future due to the changes of digitalization? Now, before having a look at the future vision, let's first again have a look at how things are currently done. So in the development process, you would have the respective regulations in a human readable document like the OIML R76. And at least in our company and probably in other companies as well, there are dedicated metrology experts to translate the requirements in this document to the product development team in so-called user requirement specifications. But this is not done on a one-to-one way, but one URS could contain contents from several parts of the original document and vice versa. And after having developed a respective device, the product development team would provide respective proof and documentation, again back to the metrology experts, in the shape of pictures, Word files, Excel files, PDF files. But again, you would find the answer to, for example, user requirement specification number 1, maybe in this picture, but the answer to user requirement specification number 2 in this Word file and in this Excel file. So you do not have a one-to-one translation of the user requirements to the documents. And so in the end, again, the information from the different documents has to be transferred into documents like it is required by the respective notified body. Now, what happens after the notified body has received all respective documentation? First of all, they will check for completeness of the documentation. There might already be unclarities which information can be found where, so that the notified body approaches the manufacturer, and in the worst case, the respective metrology experts have to ask the product development department where to find that information before finally the completeness is checked. Afterwards, the notified body will check the documentation for correctness, and again, in the worst case, there might be unclarities and respective inquiries through the manufacturer. In parallel, the measurements of the respective devices are conducted. If everything is correct, complete, and compliant, the notified body will issue a draft certificate supply it to the manufacturer, and after confirmation of that draft, the notified body will finally issue an approval certificate. In our case, as a European manufacturer, in the first step, we always apply for a European type examination certificate and in parallel for an OIML CS certificate. After this first step of approvals, we would then submit the European type examination certificate and the OIML CS certificate to notified bodies of countries which are not OIML CS utilizers, like Brazil. Even if they are formally not accepted, we consider it as a proof of compliance to be submitted to the notified body. But there again, of course, the same process starts, so the documentation is checked for completeness, checked for correctness, the measurements are conducted, a draft might be issued and confirmed before we receive the final approval certificate. It looks a little bit different for countries which are OIML CS utilizers, where we only submit the OIML CS certificate to the notified body. Again, of course, the completeness is checked of the documentation and the correctness, but no measurements are performed until we receive the approval certificate of such an OIML CS utilizer, like, for example, China. Now let's finally have a look at a vision how processes in legal metrology could look like in the future due to digitalization. You would still have human-readable formats of the regulation, but in parallel there would be machine-readable versions of the regulation, a collection of mathematical clear requirements. These could be more or less directly transferred to the product development team as user requirement specifications and really on a one-to-one basis. So requirement number 1 from the R76 would be URS number 1 and so on. The product development team could supply respective implementations for the single requirements from the regulation. So implementation 1 being the answer to requirement number 1, possibly of course with additional documents giving evidence for the correct implementation, and this could directly be forwarded to the notified body. The advantages are clear. Due to the clear mathematically formulated requirements, you would have less unclarities. A solution or implementation for a particular requirement of the regulation is easily findable. You would have the possibility to validate the different implementations against their requirements at any point of the process, so already after the product development team has submitted them or at the notified body. The information provided in the collection of implementations is reusable for other further pro steps in the legal metrology lifecycle, and of course, as such, you would save time and money. For the approval process, the vision would look like as follows. The implementation collection as documentation, together with the respective evidences, is transferred to a respective cloud system, where it is automatically checked for completeness. Different notified bodies all over the world can in parallel check for correctness and confirm that everything is complete and correct and that the evidence is accepted, and respectively then submit, of course, the certificates, or even better, machine-readable digital certificates of conformity, which can then be transferred to certificates. And also for the further process or the further steps of the life cycle of the instrument, the production process and the market process, you could imagine that when in the cloud the different implementations are stored machine readable and the respective certificates from the notified bodies are stored machine readable, all this information can be accessed by the different stakeholders. For example, the manufacturer could at any time submit revision information, which would then of course have to be accepted again by the notified bodies. In production, the manufacturer can validate the parameters of the devices against the approved implementations, and the manufacturer can provide additional conformity assessment data, product audit data, and zero series data to this cloud system. The notified body would respectively directly revise approvals via the cloud system and possibly also approve software updates. The user can, via this cloud system, register at the respective verification authorities and possibly directly obtain the approved software updates. The market surveillance could schedule surveillance and re-verifications based on the data that is available in the cloud. They could determine risk-based re-verification intervals based on the information in the cloud. They could compare devices with the improved implementations to check for compliance, and of course always obtain up-to-date information. And you could of course also imagine that devices might be connected directly to this cloud system, which on the one hand would allow for installation of approved software updates and also for partial remote verification. So the market surveillance could check, for example, via the cloud system, if the software version on the device is the currently approved one, if the audit trail shows any abnormalities, and so on. To summarize this presentation, it is no big surprise that digitalization can and will serve all involved stakeholders in legal metrology by reducing transmission and copy and paste errors, by saving time and money, and by easing and optimizing processes. It is a very important point from our view that regulations must be very well structured to become machine readable in the future. We think that a trustworthy cloud concept, as demonstrated, is needed. And it is important for us as a global manufacturer that all digitalization approaches should feature global thinking and not be limited to national or regional implementations. Before coming to the end, I would like to take the opportunity to cordially invite you to the first international conference of weighing that will take place in April next year in Hamburg in Germany. The conference is organized by different partners, including REMESP, and is hosted by CESIP, the European Association of Manufacturers of Weighing Instruments. Visit weighingconference.com or use the QR code given here to find more information. I do not know the detailed program of the conference yet, but there will be several sessions about legal metrology, applied metrology, and scientific metrology, and I'm quite sure that digitalization will be an important part of many of the presentations given there. So I hope you enjoyed this presentation. I would like to thank you for your attention, and I would like to thank the organizers again for the invitation to this seminar. If you have any questions, feel free to contact me at any time via the contact details given here at the bottom left. I wish you a successful seminar and fruitful conversations, and I hope to see you next year in Hamburg. Thank you very much.